Guys, this is very important concept in the freshwater generator. If you understand this, you will not have any problem with understanding the concept of vapor and the vacuum and the shell temperature. So this is the relationship between the vacuum and vapor. I have taken a case over here, and through some cases we will try to understand how the vacuum changes with the change in production of vapor or the shell temperature. So always remember, first the vacuum changes and then changes the shell temperature. So your vacuum is directly affecting the shell temperature. So shell temperature and vacuum are interrelated. One will change the other. So always and always you have to see that the vacuum will change, because the vacuum is the whole and sole reason why the freshwater generator is working, right?
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
If the vacuum is not present, there will be no evaporation, because you are boiling the water at how much? 45 or 50 degrees centigrade. At such a low temperature, if the boiling point is working only due to vacuum. So vacuum is the only thing that is to you have to see, and you have to maintain and point out when your freshwater generator is running. So what is the relationship? And vapor, what is the vapor? Vapor is whatever steam is produced or the vapor is produced from the evaporator. Now see this, as simple as this. Say vacuum is dependent on vapor. How I talk about this? So this is the cell, right? It has got one. This is the evaporator section. This is the condenser section. Here you have a vacuum gauge fitted, and here you have a shell temperature gauge, temperature indicator fitted. Okay. So what temperature this indicator is taking? Whatever is the material present over here inside the casing. So this is the casing temperature, right? The shell temperature means casing temperature. Outside temperature is not related to the condenser, neither to the evaporator. No matter whatever is going on inside the condenser or evaporator, the shell temperature will take the temperature of whatever material is present in the casing. Okay, noted. And vacuum is also, gauge is also located in the casing. So what it will check? It will check how much is the vacuum present in the casing. Noted. So if what will depend on, what will change this vacuum? Say initially you achieve 90% vacuum. What will change? Here you are producing steam, you are producing vapors. These vapors are continuously flowing towards the upside. This vacuum, these vapors are going from here to the upside, and then going inside the condenser, upside. So if the, say, condenser is not condensing, in that case what will happen? More amount of vapor will be collected here in the casing. So vacuum will be lost. Why? Because there is something which is obstructing the vacuum, right? There is something, like if it is air or if it is vapor or anything which is present, will cause the vacuum to reduce. So if your vacuum was initially 90% and your condenser is not able to condense, it will fall down to 80%. And so will the casing temperature, because the steam is present inside over here. So what will happen? Shell temperature will start rising 40 to 45 to 50 degrees centigrade. That means the steam produced is not being able to condense. So that is the funda. If your vapor is excessively present inside the cell, your process is not getting completed, your condensation is not happening. In that case, your vacuum will be affected, right? The cases can be if your shell is also getting filled up with water, brine is not eructed. In that case also, your vacuum is not present in complete cell now. so the vacuum will also drop in that case. Okay, now let us take an example over here. We see that we will fix the fresh water, say seawater temperature to 10 degrees centigrade. Now we will see the effect of seawater temperature. We will see the effect on the change of the other parameters. Like we change one by one condenser, evaporator, and we will see what all things change in the freshwater production. So we see one by one. So seawater temperature is 10 degrees centigrade, very cold. So as cold is your seawater, it is better for the freshwater generator to work. So why I should say that? Because at very less temperature, evaporator is directly dependent on the jacket water temperature. So as your jacket water temperature is being heated up, there is no problem in getting heated, because only 40 to 45 degrees centigrade you are needing to heat up the water. Main advantage you are getting in the condenser, because as cold is the seawater, it is faster, the cooling rate will become very fast. So as the steam will come, it will go inside the condenser plate, it will condense, and the distillate pump will pump out the water. So faster condensation rate will be achieved in that case. So cold temperatures, your freshwater generator will work very well. The problem happens when your freshwater generator is working at in higher temperature zones. But very cold temperature, 0 degree centigrade, also problem. In that case, the condenser will also not be very effectively working. So optimum is 5, 10, 15 degrees centigrade, your freshwater generator working fine. 30, 35 degrees centigrade seawater temperature, the freshwater generator will start giving problems. Okay, let us take a case. Now in this case, I see that my seawater temperature is 10 degrees centigrade, very good for cooling. So condenser is okay. Condenser is not choke, condenser working very fine. But my evaporator is choke. What effect it will do to the vacuum? Okay. So evaporator is choke, orifice, here my orifice is present in the feed water line, this orifice is okay. So the water is going, but evaporator is choked with salt scale. So what will happen? In that case, since your evaporator is scaled, jacket water will go, jacket water will come out, steam production will be happening, but the vapor will be less produced. Okay, whatever vapor will produce will go up, will be easily cooled by the condenser, and easily the fresh water will go out. Okay, now since there is nothing which is causing problem with the vacuum, because the whatever vapor is present, it's getting condensed. Okay, in that case there will be no problem with the vacuum. You understand? Even if initially I had this perception, right, that if your evaporator is choked, it will completely heat up the unit, and the cell temperature will also rise, even your vacuum will fall. No, certainly not. If your vapors are being produced and consumed in the right quantity, and there is no vapor accumulation inside here, the vacuum will not be falling. In this case, what will happen? Because condenser is condensing everything that is coming in its path, the vacuum will be very good, actually 95% vacuum. Even so, and 95% vacuum, even there is no vapors in the cell present, so the cell temperature will also be optimum 40 degrees, 45 degrees centigrade. But your freshwater production will drop in this case. Initially, I had a perception that a vacuum has to drop and cell temperature has to rise. Only in that cases your freshwater production can drop. So freshwater production will definitely drop in this case. Why? Because the evaporator itself is choked, so it is producing less amount of steam and less amount of water is being produced. But the vacuum is steady. Vacuum is even better. Okay? You understand, guys? Second case, seawater temperature is 10 degrees centigrade. Condenser is also okay. Evaporator is also okay. But my orifice is choked. That is the feed water inlet line here. Orifice is choked. So in that case, water is also going less, but evaporator is working very good. In that case also the same thing will happen. In that case also same thing will happen, because water is going less, So your evaporator is able to evaporate whatever water is coming very easily. Very easily. Water is going as vapors and is directly going into the condenser, and condenser is condensing everything. Vacuum remains unaffected, cell temperature remains unaffected, but production drops. So you see, cell temperature remains affected, vacuum is also very good, but production, freshwater production drops in this case. Okay, third case. In this case, we see that seawater temperature is 10 degrees centigrade, same, condenser okay, evaporator also okay. Orifice size hole increases, bigger size, orifice becomes bigger. So in this case, what happens? Feed water ratio disturbed, more of feed going inside, more of feed going inside. So more water going inside, evaporator is over capacity, steam is going. So it will go, and what will happen? As much amount of steam it will be able to evaporate, it will evaporate, rest will fall here, will fall, and the brine reactor will take out. Okay. But in that case, what will happen? In that case, what will happen? The steam produced by the evaporator in that case will be more than previous, because your evaporator plates are working more than the feed supplied. Okay, it has got more feed, so more salt, more evaporation is taking place, even because it is overworked, so maybe salt carryover is also taking place. In that case, what will happen? Your vacuum will drop. Why? Because you have extra vapors present, more than the capacity, extra vapors present. Vacuum will drop and cell temperature will increase. Why? Because the steam which is coming in directly contact with the temperature indicator, temperature transmitter, will increase the cell temperature. Simple as that, because steam is present here. So cell temperature will increase. Cell temperature increase, vacuum drops. Okay, because steam is present over here. Then it goes to the condenser, but even then, because extra steam is being produced, more steam is present on the condenser. Then this steam will have a chance of having salt also, because faster rate of production, salt carryover. So when the water will be condensed, the fresh water will be condensed over here, there is a chance that the salinity will increase. Production will increase in this case, but salinity will also increase. Okay, so in this case, orifice will happen, vacuum will drop, production will increase, and salinity will also increase in this case. So in the three cases, we have seen the changes with respect to the feed water and with respect to vacuum, how with respect to vapor, the vacuum changes, the cell temperature changes, and the production changes. Okay. In the next one, I am going to discuss something more important with respect to the understanding of this relationship. Okay. Thank you.